So in this question, we're being asked to solve the simultaneous equation, and it's got logs involved, which is something that we're not used to seeing when we're solving simultaneous equations. So we're going to need to come up with a way to rearrange these equations so that we don't have logs involved, and there is a way around that. So I'm going to color coordinate this so we can keep track of what equations what. So the first one here I'm going to do out in yellow, and I'm going to simplify it as much as possible. So I've got log 2x minus log to the base 3 of 3. Now it might send off alarm bells first and foremost that they're not in the same base, but if you look closer, you'll see that actually it's log to the base 3 of 3, which is a number. You should know that if the base matches what you're getting log of, that's going to be 1. So what I would do straight away is change that into 1. So what we really have is log to the base 2 of x minus 1 is equal to log to the base 2 of 1 minus y. So what I have here then, I can rearrange that and swap things around. So I'm going to have log 2 of x, and then I'm going to have minus log to the base 2 of 1 minus y is equal to 1. And what I could do with that then is when I subtract in logs, what we actually have is division. So I'm going to have log to the base 2 of, and then it's going to be x all over 1 minus y is equal to 1. And then what we're going to need to do is get out of logs. And there is a way that we can get out of logs, and it's through the formula a to the x is equal to y, log a of y is equal to x. And I keep referring to this as the golden rule because you're just going to use it so often to translate to and from logs. So a to the x is equal to y, log a of y is equal to x. So identify what each thing is. So my a here is what our base is. So our base here is 2. Our y is what we're getting log of, so it's going to be x all over 1 minus y. And then our x is going to be 1. So you're just following the formula. So we're going to have 2 to the power of 1 is equal to x all over y minus 1. And we can rearrange that then, multiply up by y minus 1, and we're going to get 2 minus 2y is equal to x. And then we're going to rearrange that so we get x plus 2y is equal to 2. And this is the first equation, a linear equation, which we can handle when it comes to simultaneous equations. So now that we have our linear equation, we're going to go back up to the other equation in log to the base 2, and we're going to see can we rearrange that so that we get a linear equation. So what we have is log to the base 2 of x minus log to the base 2 of x plus 2y. So straight away what we can do with that is we can write that as a single log. I'm just going to copy and paste it so we bring it down so that we can see what we're working with. We can write that as a single log using the exact same rule as before. We're going to say, all right, when I subtract, I divide. So I'm going to have log to the base 2 of x all over x plus 2y, and that's going to be equal to 3. And getting out of logs now again is going to be the exact same rule. So if we want to get out of logs, we're going to use this rule here. And again, I call it the golden rule because you're just going to use it so often when you're dealing with logs. So it's converting to and from logs. So looking at that then, our a is going to be 2. So we're going to have 2 to the power of our x, which is 3, is equal to y, which is x all over x plus 2y. So that's what we're going to be dealing with. And arranging that then, we're going to have 8 here, but I'm going to multiply up. So I'm going to have 8x plus 8 times 2y is going to give me 16y is equal to x. Take away x from both sides and I'm left with 7x plus 16y is equal to 0. And that's my next equation. And we're going to combine that with the other linear equation so that we can solve a linear simultaneous equation. So what we can do once we have our two linear equations is we can stack them like we would usually do with two equations with two unknowns. And we're going to change one of the equations and I'm going to change the first one. So let's pick the first equation here, and what I'm going to do is I'm going to multiply everything through in that line by minus 8. So I'm going to have minus 8x minus 16y is equal to minus 16, and I'm not going to change anything about the bottom line. So this is a skill we should have from junior cycle, solving linear equations with two unknowns. So we've got 7x then plus 16y is equal to 0. So combining these two together then, what I'm going to have is I'm going to get minus 8x plus 7x leaves me with negative x, minus 16 plus 16y, that goes to 0, is equal to negative 16. Now I don't want to know what negative x is, I want to know what x is. So what I'm going to do is multiply both sides by minus 1. So I'm going to have x is equal to 16, a positive 16. Once we have our x then, we're going to go back and we're going to substitute it back into one of our equations. So I have here x plus 2y is equal to 2. I'm going to take out my x from that and I'm going to replace it with 16. So I'm going to do that. So take out our x, replace it with 16. And now we have one equation with one unknown, which we can solve. So I'm going to have then 2y is equal to 2, take away 16 from both sides. 2y is equal to minus 14. So y is going to be equal to minus 14 divided by 2. Y is minus 7. So there we have the solution to our two simultaneous equations that started out with logs. And you can go back and check your answers by substituting in your values for x and y, making sure that you don't get any negative values for your logs.